In 1991, during the Gulf War, a massive aircraft circled slowly above the battlefield. Not a fighter jet. Not a bomber. But something far stranger, a cargo plane firing artillery sideways out of its fuselage. On paper, this idea should be absurd. Aircraft rely on lift and aerodynamic stability. Firing heavy cannons sideways introduces massive recoil forces that could destabilize the plane entirely. So the question becomes, how do you turn a transport aircraft into a stable, precision artillery platform in the sky, without breaking the laws of physics? The answer is the engineering behind the AC-130 Gunship, built on the legendary Lockheed C-130 Hercules platform by Lockheed Martin. And to understand how it works, we need to start with the physics problem engineers faced. Modern warfare often requires close air support, helping ground troops under fire. Jet fighters are fast and powerful. But they have a critical limitation. They move too quickly to stay over a single target. A fighter jet traveling 900 kilometers per hour can only attack a target for a few seconds before it must circle back. Ground troops needed something different. Long endurance. High precision. Persistent firepower. In other words, they needed artillery, in the sky. So engineers looked at a cargo aircraft, the C-130 Hercules, known for its durability and long flight time. But turning a cargo plane into a flying battleship introduced a massive engineering constraint. Every gun obeys Newton's third law. For every action, there is an equal and opposite reaction. When a cannon fires, the projectile moves forward, and the gun pushes backward. For large artillery, this recoil can be enormous. For example, the M102 105mm Howitzer used on some AC-130 variants produces tens of thousands of newtons of force. Visual, diagram showing recoil force pushing backward on aircraft frame. If this recoil acted directly sideways on an aircraft in level flight, it would create a rolling moment, essentially trying to flip the plane. And yet the AC-130 fires continuously while maintaining stable flight. So how is that possible? The answer lies in one of the most clever flight patterns in military aviation. Instead of flying straight toward a target, the AC-130 flies in a constant circular orbit around it. This maneuver is called a pylon turn. Visual, top-down animation showing AC-130 flying a circular orbit around a target. Here's why this works. When an aircraft turns, it banks its wings. This banking creates centripetal force, pulling the aircraft toward the center of the circle. That force also stabilizes the aircraft against sideways disturbances, including gun recoil. So when the AC-130 fires its weapons out the left side of the aircraft, the recoil is partially absorbed by the turning force of the aircraft itself. In other words, the plane's flight path helps counteract the physics of the gun. It's a clever example of using aerodynamics to solve a ballistics problem. The AC-130 is not just one gun. It's an entire airborne weapons system. Depending on the variant, the aircraft carries weapons like GAU-12 equalizer 25mm rotary cannon, 40mm Bofors autocannon, M102 105mm Howitzer artillery cannon. Visual, exploded diagram of AC-130 showing weapon placement. The guns are arranged along the left side of the aircraft, all pointing toward the same ground point during the orbit. But precision doesn't come from the guns alone. The real secret is sensor fusion. Modern AC-130 variants combine infrared cameras, radar, laser targeting, ballistic computers, visual, overlay of sensor feeds targeting a ground vehicle. These systems calculate wind speed, aircraft motion, bullet drop, atmospheric density, all in real time. Because at several kilometers altitude, even small variables can change where a shell lands by dozens of meters. The AC-130 is incredibly powerful, but it has serious limitations. First, speed. AC-130-based aircraft cruises at a... The true innovation is stability and targeting. Anyone can mount a cannon on a plane. But keeping that plane stable while firing artillery, at night, while orbiting a target, thousands of meters below. That requires a combination of aerodynamics, ballistics, and computer systems working perfectly together. The AC-130 Gunship is not the fastest aircraft. It's not stealthy. And it's certainly not cheap. But within its mission, persistent, precision fire support, it remains one of the most effective platforms ever built. It works because engineers didn't fight physics. They designed around it. By combining orbital flight patterns, recoil management, sensor-driven targeting, they turned a cargo aircraft into something that behaves like a flying artillery battery. And it's a reminder of something fundamental in engineering. Human ingenuity can push technology incredibly far. But it always has to negotiate with the laws of nature. If you enjoyed this kind of deep dive into the engineering behind military technology, subscribe for more videos breaking down the physics of machines that shape the modern world. Because sometimes, the most powerful weapons aren't just built with steel. They're built with clever engineering.